So, hello everybody. I hope you had a great start of a day, and let me introduce my co-speaker, Marharyta. She's a staff software engineer at Sonar, my colleague. She's also a Kotlin Google developer expert. You could find her on various social networks if you want to chat.
And I'm really happy to introduce my colleague and co-speaker Evgeny, who is principal software engineer at Sonar. He's also by chance JaCoCo project co-lead, so he's responsible for the code coverage stuff during our talk. And like recently in June, he became a Java champion. We forgot to update our slides, but he's, and you can find him as Godin in Twitter and in GitHub.
Well, one more thing before we start. We work in a great company, Sonar Source, creators of product SonarLint, SonarCube, Sonar Cloud. So just for a quick check, who knows this company, who uses these products, don't be shy. That's pretty impressive. But whatever we are going to say today has nothing to do with this company. Whatever we are going to say is our own opinion, and our employer can only dream that they own this opinion. Are we ready? Did I forget something?
I think there is one more important thing you should know. I am Ukrainian. I was born and raised in Kyiv, and only for a few years I live in Switzerland. And today you probably heard that my country is struggling. We have huge problems with our nearest neighbors. So if you feel like you want to support Ukraine or do some donation, this is a trusted charity fund. You can use this link for donations. And thanks a lot for those of you who stand with Ukraine. That really matters. I think the most important and the most serious part of the talk is done. Now let's have some fun.
Apparently I'm going to be responsible for fun part of this talk as well.
Ooh, we are all doomed now.
Okay, so Mythbusters. What this is going to be about?
Actually, our talk is inspired by the TV show of Mythbusters. Maybe a quick check. Have you ever seen this TV show? Oh, I remember this from my childhood. I really enjoyed it, and we decided to do something similar. So for those who never seen the Mythbusters, in simple words, there are two guys that try to collect some interesting beliefs, myths, and common disbeliefs, and they try to reproduce the circumstances and either prove or dispel this myth. We are going to do the same, but with code coverage here.
And let's figure out what is going to be our first myth.
I think since Evgeny is for a long time in code coverage, I'll let him decide.
Well, I propose to actually ask audience. So, simple, stupid question. You write your software. You probably, hopefully, write the tests. Do you have any code coverage target when you write the tests? How much of your software should be covered by tests? What do you think? Like, maybe zero? Like, we don't write tests, just ship into the production. If users are not happy, we will rewrite things. Who thinks it's a good target? I actually do. It's pretty neat one. Okay? Maybe 30%? Who thinks 30
Don't be shy,
is good?
raise your
Don't be
hands.
shy, wake up. Yeah, 30, yeah, pretty good one. 60? Nobody? Wow, you're really good at writing tests.
Oh, really bad.
80? Yeah, 80. Pretty much many people nowadays agree that 80 is a good target.
From where this number is coming, I have no idea.
Just industry standard, like for everybody it's easier to cover 80%. There is some people who say that the only target is 100. Like, do you agree?
I think it should be 100.
It should be 100, no? Isn't it?
Yeah, that's what we target at Sonar.
So, the ones who didn't vote it for everything, you think it should be 110, I guess, right? I think this one is great, like above the expectation. So, that's going to be our first myth. Code coverage should be 100%.
Yes, I think even for those of you who raised your hands for 80%, it's still like you feel, okay, I'm doing for 80% because I go like on some compromise, but it should be 100. And we need to cover 100, and in ideal world, we should be 100. And this is even written in some books. well, some people, that code coverage should be 100. Today, it will be our main myth, and we'll try to make it 100 or either prove that it's impossible. So in simple words, it means that if you write one line of code, you can always write a test for this line or this instruction in your code. And we decided with Evgeny to go the same way. We chose a ping-pong pair programming. One will be writing code, another one will be writing tests, and we'll try to see if we can reach 100% of coverage. And because I am a responsible engineer, I prepared everything beforehand, and because I didn't get a hands-free
I thought you're going to be coding now.
And Evgeny is not that responsible, so he'll be going live. And he'll be writing tests live here, and if something goes wrong, it's definitely his fault.
Okay, so I hope everybody can see. If not,
I don't think let's enter presentation mode.
Let's try to do like this. It's better. So, pretty simple, stupid. First example, Marharyta wants me to test sum. Should be easier, like 2 plus 2. Oops.
How much time principal engineer need to figure this out?
Did I open the right test? 2 plus 2. Sum. I think that's it.
Cannot write 4?
What? It's a good test, no?
Okay, let's check.
So, let's start our tests. Let's generate code coverage report.
Andreas is not here, you can write clean install.
No. Nowadays we should write env and verify. So, build is successful. Let's look at our code coverage report.
Okay. We forgot to ask the audience what they think, but...
Ouch.
I guess...
What?
We all just saw that he wrote a test, and we expected 100% coverage, or at least some coverage. And you know what? It's 0. And I think it's my fault, because I prepared everything in advance, and I forgot to tell you something.
But you said that any fault during coding is going to be my fault, no?
I lied, probably. So could you please open the test?
There is a test?
Yes, and from where you're taking this test annotation? It's org JUnit test.
It's JUnit 4, yes?
Yes.
I love JUnit 4. What's wrong with it?
Nothing wrong, but I think I use JUnit 5.
You mean that I'm quite old? No?
Yeah.
But so I know that JUnit 5 should be able to execute JUnit 4. What's the problem?
Yes, but you need to add an additional dependency to tell JUnit 5 that there are going to be tests for JUnit 4, that they need to use the separate engine, special engine for JUnit 4. And we didn't use it. So if you just add JUnit vintage engine, we'll be able to write tests. So that's interesting. We looked at code coverage and we realized that there is something wrong with the project. And it has nothing to do with the coverage of the tests.
Oh, now it's better.
Yeah, much better here. So it also made me think that we dispelled our first mini myth. Can you get back to our slides?
Sure.
That 0% of code coverage is always bad. Because I think we all believe that 0% is always bad. However, it's not true. Sometimes 0% of code coverage can tell you that something is wrong with your setup. For example, here we forgot to add a dependency, and the only way to figure this out was by looking at code coverage.
No. Not the only way. I think we forgot one more thing, like developers usually forgot to do this, and I forgot to do as well. Build was successful, but if we carefully look at the log, we could see that no tests were executed. No need to blame code coverage tool if you don't execute your tests. And you know what?
What?
You just said code coverage is a good debugging tool, right?
Yeah.
This gave me an idea. Do you use Eclipse by chance? Who uses Eclipse? Nobody? No, there is few guys. But it's not at all connected with Eclipse. I'm just going to be using Eclipse as an example. You can do the same with Tomcat, JBoss, Spring Boot, IntelliJ, whatever. I'm just going to be using Eclipse because it's a nice example. Because you could see that I also don't use Eclipse. I love IntelliJ, I use IntelliJ, but together with JaCoCo, I kind of inherited or got another project to maintain. It's actually Eclipse plugin for JaCoCo. And I know nothing about Eclipse. Like, I don't use it, I don't write plugins for it, but I got a project that I need to maintain. Our user does some actions, like he wants to run the application with coverage. You see the spinner, something going on, right? And user looks into his console and sees there is plenty of exceptions, like something does not work. And if you look at those exceptions, probably it's a little bit small for you, but the top of stack trace doesn't contain anything about the plugin. Like plugin is org eclipse equal Emma, but the top of stack trace is org eclipse core. So if user are gonna send me this report, I have no entry point to start investigations. I don't know where in my project to put a breakpoint, which code is responsible for this exception. But what is possible is actually, it's possible to generate code coverage report from the live instance of application. And that's what we're gonna do. So we see that some code was executed. This includes startup of the plugin, etc., etc. We are not interested in it, so we're gonna reset the code coverage data we collected so far. And we are gonna repeat the same action which we'd like to debug and investigate. So we hover mouse. The same exception happens. Now we're going to request the code coverage again. And the only thing that is remaining is this one, code coverage launchable tester. And this is exactly the code responsible for exception. So we can start debugging from there.
So technically, we can use code coverage to identify which code was executed in production and try investigating from this point. And it's, I think we just got to another point where we just showed that code coverage is not only used to measure coverage, it could be used as a debugging tool in some circumstances.
Should we move on?
Yeah, let's continue with the next example. I think this one is more interesting for you.
Okay. What do we have here?
Here I have a simple switch statement.
Okay. Switch by enum 222, and I need instance of this class. Okay. Here is an instance. What do we want to assert? We've been at DevOps Morocco in Marrakesh, so that's the best conference in the Marrakesh city. We have been in Horvatia at JaCoCo. This is also a conference. So that's it. I think enum has two values. I have two assertions. Should be good.
I don't know, but let's try.
Okay.
I feel we are missing something, but let's run the test. So this time, everything run?
I hope. Yeah, test run. Oh no.
But something is missing here, you see?
Still not 100. Default case. But
JaCoCo tells us.
come on. There is two enum values. I cannot cover the default case.
I think you can. You can, but you need to use mocking. Do you use mocking in your tests? So you see, it's a common practice, I think.
I don't like this practice, so I don't use, but let me try. Let me mock. Here is my mock. So, do return. Yeah, okay, now, when mock best conference revenge, assert equals
You really want to offend JaCoCo.
Now, mock best conference revenge. Yeah, I think it's good. I can even simplify this, but okay.
With assert null, I guess, yeah. You know what?
No. Mocking doesn't work. Like, this is the most common thing that our users tell to us. Mocking is not compatible with code coverage. Mocking does not work with code coverage.
You
That's
think
it.
so? Like
Yes, look.
You saw half of the audience raise their hands that they're using mocks. And do you think they can claim that it doesn't work with code coverage? I think it works if you know how to write mocks. I'm sorry to tell you that, but I think your mock is wrong. Let's look at the code that you wrote. You wrote that when we execute best conference function on a mock, we should return something predefined value.
That's what we wanted to test.
Yes, you never mock the function that you want to test. You should not mock the function that you want to test. You need to mock the dependencies of that function. Because, of course, it's not executed because that's what you told the unit to do and what you told Makita to do.
And you want me to mock enum?
Yes, you need to mock enum.
But that's crazy. Enums are final in Java.
Do you want to reach 100?
Okay. Let me try to mock final. I don't believe in this, but... So, do return -1 when mock ordinal. And assert null when best conference from mock. Is it better now?
Yes. Let's try.
Okay.
Silence, like we are praying.
Okay. Yeah, I'm praying. 100. Wow. That's impressive. Okay.
You see? You learned today that you can mock enum and achieve 100%.
But it still sounds like a black magic to me, like final enum. How can you mock the final? Can I try one more thing, please? Like which Java version?
Please don't.
Which Java version I use? 21. You know, I don't like black magic because with new releases of Java, black magic has a tendency to break. So can I try to use latest early access build of Java that is currently under development?
During our talk.
During the talk,
live demo.
Yes.
So usually people don't recommend to upgrade your dependencies before the talk. We went further. We are doing it during the talk.
24 early access build 18. Like, what could go wrong?
I don't like this.
Let's see. Bam. What's going on? Let's see.
So you saw the only thing that we changed was the Java
Makita
version.
cannot mock this class anymore. Oh no. That's bad, right?
Okay.
I don't like black magic. You see, it's so easy to break. Can we maybe be a little bit smarter? Why we need such a black magic tricks if we have Java 21? In Java 21, we have a switch expressions. So let's maybe refactor this code a little bit. Let's use switch expression. With switch expression, if it's exhaustive, we don't need default anymore. So let's remove the default. We can even simplify that code. And it looks much better, right?
Okay, and you can remove the test.
Yeah, let's me remove the mocking. Are we gonna get 100%?
Okay. Anyway, you see, code coverage helped us refactor this code.
100. Is it the correct code? Yes.
Okay.
It's much better. You don't need black magic.
Okay. So first of all, we proved that code coverage works with mocks, and if you had some doubts. Let's continue. I think I have a few more examples.
Okay.
Why one? I have a lot more for you.
A lot more. What do we have here? Sealed interface, record. Oh, you actually know how to use switch expression, right?
Yes, I just wanted to catch you.
Example, free test. That shouldn't be that hard. So you wanted me to compute perimeter of a rectangle. Okay. I need to call that function.
You know, fun fact that actually rectangle with A2 and B2 is a square.
What? Our goal is to reach 100%. It should be good. Good test. All cases, switch expression, should be good. Okay.
Okay, let's look.
What? Come on. What's going on here? Like, there is two branches cover it.
I
What's
told you
here?
upgrade in Java was a bad idea.
2 out of 4 branches missed. That's weird. 1 out of 2 branches missed. But there is no branches on those 2 lines.
As I told you, upgrade in Java
Java?
during the talk is a bad idea.
Okay.
Let's get back to
Let's go back to
LTS.
21. Oops. Right. Where is Andreas, who is going to tell me to not use clean?
I think he is in Thessaloniki.
Ah, here we go. 100%. So, what you're actually saying is,
Yeah, unfortunately, code coverage results might depend on the compiler because JaCoCo is analyzing your bytecode, and bytecode changes.
yes, different compiler versions produce different bytecodes. There might be some quirks and tricks in the bytecode, so we have one more thing to fix in JaCoCo to pretend that there is no, I don't know how many, 6 branches, but just 2 in this case.
Yeah, thankfully we know who to contact for this.
Next example.
Yep, let's proceed.
Oh no, there is no examples.
Example 4.
We've been at example 4, no?
No, I guess it was example
It
3.
was 3, okay. Example 4. Okay, so it's again the best conference, but this time it's a little bit more complicated, but okay, so
This time we decided to return optional instead of just returning the value. But I think as you already covered these cases, it probably should be easy.
yeah, there is switch expression, it should be easy. So again, devox map.
Where's your copilot today?
I disabled it.
Come on.
I don't like it.
AI is the future.
I don't like it. Should be good, isn't it? And this time, just for the sake of change, maybe why we are talking about JaCoCo, there is plenty of other code coverage tools, like Sonar can show you coverage.
I think you can run coverage in IntelliJ.
Yes, we can run tests with coverage in IntelliJ.
Have you ever run the tests with coverage in IntelliJ? Or do you at least know where this button is?
You see, 100 from the very first shot.
Okay. If we just started and go in this direction, let's try Sonar.
I did this in advance, so here is our shiny example, 100%.
I'm surprised how you could do it in advance if you just wrote your tests.
Just to not spend time of audience. So it's the same code, 100% coverage, all good.
Okay, even some issue, yeah? Probably commented out.
Yeah, fix me.
Fix me. Okay, and interesting fact about Sonar for those who don't know, Sonar does not compute coverage. Sonar uses your JaCoCo reports and just reads them. So it means that if we run JaCoCo reports, we expect the same result.
Yes.
Do we?
Yes.
Let's
IntelliJ says 100, Sonar says 100. JaCoCo is gonna say 100.
Let's check.
What? What? Okay, I know. Look at missed lines. There is 0 missed lines. There are 0 missed branches. And Sonar shows exactly that, missed lines and missed branches. but not missed instructions. And we have missed instructions here at line 16. Can I try something?
So technically, JaCoCo is right. It just shows the results more precisely. And for some reason, we don't have, like for known reasons, we don't have instruction coverage in Sonar, but maybe it will appear, who knows.
Yeah, we not only need to fix JaCoCo, we need to fix Sonar now.
So indeed, we never tested the case of exception, and that's why this line is never covered.
Now it's line 17. Not a case of exception when load conference returns actually empty optional. Okay, let's test this. And you showed me how to use mocking, so this time...
Should I regret?
No, this time I'm going to be using mocking, so let me spy and Makita do return optional of nullable null when spy load conference from this city, and we want exception, we want runtime exception. When
this time you learned that you need to mock your dependencies.
Yeah. Should be good now.
Yeah, let's check. So indeed, we forgot one case, and JaCoCo told us about this, and we covered it. However, like since we already went that direction, we tried Sonar, we tried IntelliJ, we tried JaCoCo. Let's try something else. Probably there was a talk today about mutation testing. Have you heard about it? So for those who don't know, it's a technique when we introduce the changes in our, when the tool introduces changes to your main code, and then execute tests. And if tests fail, it means that you caught this mutation. But if it did not, it means that there is some modification to your code that is not tested, and you need to look at this. We will use today ptest for this, and Evgeny just run it. And we'll see what it shows. It shows that indeed there is something missing. There is some mutation in our code that still made all our tests pass.
Replace at return value with null for the first lambda in getBest conference. Survived. Which means that ptest said that what? Replace at return value with null for the first lambda. So if we replace this return value with a null, ptest says that our tests will still pass.
That's interesting.
And indeed, our tests still pass. What's going on here?
I think I know what's going on. Do you? So what we are saying here that we expect runtime exception. And indeed, when we return null, runtime exception happens, because null pointer exception is also a runtime exception. And our tests, they get null pointer exception, and they think that's something that is expected because it's still runtime exception. So in order to have more precise test, we can probably check the exact class or check the message.
We probably want to check the message, and this time, if we return null, our test should fail. Yes, our test fails. Expected conference not found, but was cannot throw exception because the return value is null. Yay! So let's fix the code.
So you see mutation coverage found what JaCoCo could not find. And if you're even not using mutation testing, be careful with expected exceptions and make sure that you test the messages or exact classes, or you can have such situations as well.
Again, I probably need to do No.
You need to run a mutation
mutation
coverage.
coverage.
I think we need to get back to presentation a little bit.
100 mutation coverage. Okay, let's go back to the presentation.
Yeah, so first of all, we showed you that code coverage is not the same in all tools. Even if Sonar is using JaCoCo reports, they still can show you different numbers. Then the line coverage is not enough because we missed some instruction that was in the same line, and just looking at the line coverage would not show you enough information. And another point that 100% of code coverage that JaCoCo showed us does not guarantee test quality, because mutation testing showed us something.
Yeah, okay.
And I think there is one more here.
100 mutation coverage guarantees
Quality.
That's wrong because, well, our user customer actually wanted to cover this functional requirement, loading from the database. And well, we did not, but we have 100% code coverage.
So here what I could tell you that no tool can guarantee the quality of your software because it depends on a lot of requirements, and you can use them, but you cannot just solely rely on them.
Copilot? Tomorrow? Okay. Let's move on.
Yeah. Another interesting myth that we faced, that code coverage is used to assess the quality of the project. And for example, managers look at some projects and see that, okay, the code coverage is 80 or 90% and it should be 100, so the project is bad. And they tell you to cover some missing branches or some unreachable code or anything else. And we think that that's not true. So
why? How we're gonna check this one?
Let's check the JaCoCo. This is the tool that we are all probably using to test code coverage. We relied on it a lot, millions of developers rely on it every day.
Here is JaCoCo report from Sonar Cloud. I probably should go to the main branch and see the code coverage. Ouch.
It's not 100?
It's not 100, yes, sorry.
How can we trust this project?
I think we cannot. Look at these shiny examples that we've just built with the conference, da-da-da. Even this one had 100. I think this project is just better than JaCoCo. No, isn't it? Now, let's have a look at what is hidden in these missing bits of uncovered lines. This is one of the lines written by Mark Hoffman here, about 15 years ago. And well, this works in production, it is battle tested. Do we need to fight for 100% coverage? Is this project better than example 4? No, I don't think so. This is exactly the same example as you've seen at the very beginning of our talk. This is switch by enum. And this is kind of default case. We cannot cover it because we don't want to mock it. It's stupid. We also cannot use Java 21. We cannot use switch expression. We cannot use Java 21, unfortunately, because, well, JaCoCo is still compatible with drumroll, Java 5.
I told you,
more than a decade, it just works. We don't need 100% coverage here.
So we hope we busted this. And so far we've been focused on the correctness of the coverage. Yep.
What else there?
But have you ever thought the fact that you're measuring coverage, does it actually affect your application or, for example, performance?
It shouldn't. Why would it?
Because it reminded me of the observer effect from the quantum physics, where the fact that you observe some particle actually changes the behavior of that particle. And I kind of feel that it could be the same with your code and measuring code coverage.
Let's try. This time I came prepared. So let me close it. I have a benchmark. I'm going to run it live here. And while it's running, I'm going to explain what is happening. So I have a pretty simple, stupid Fibonacci number calculator, like a little function. We don't focus on correctness, so let's don't judge its correctness. And I'm going to be measuring several cases. What if we do nothing? Like the fastest case is to not do the job. What if we're gonna compute the Fibonacci number 10? What if we will compute Fibonacci number 10 but after JaCoCo instrumentation, after recording code coverage? And what if we will do the same after recording code coverage but using JetBrains coverage engines that you have in your ID? Like those simple cases. What the performance of this is gonna be? Here is a no operation case, it's quite fast. And here is the original code. Yes, indeed, computation of Fibonacci number takes some CPU cycles, so this code is slower than do nothing. Our benchmark probably makes sense. And now, here is JaCoCo. Indeed, recording code coverage adds an overhead to your application. Well, this overhead compared to the original is not that big. But now let's look at the JetBrains coverage engine, the one that is sitting in your IDE, the one that you run, supposedly run every time that you modify your tests. It's what? It's almost 5 times slower than the original. Okay, sorry, 4 times slower than the original. I guess we just busted one more myth.
So actually it affects your application, at least the performance of it. So be careful if you decide to run it in production. And yeah, I think knowing all of that,
we're ready to wrap up?
Yeah. So what do you think? Should code coverage be 100% after listening all this?
I'm not convinced anymore.
So we think in our small speakers team that code coverage should be at the level when everything that is supposed to be covered is covered. And we know this is much harder than 80%, 100%, 90%, because it requires your brain to work. But we hope you're smart and will figure this out. In ideal world, it should be 100, but we know that the world is not ideal. We have a lot of problems, like a lot of false positives, some missing coverage, some like stuff when the compiler changes and so on. So it could not be 100, and we should not aim for it solely for 100. It would be nice if in some future there would be in tools like Sonar will have some accept or won't fix or false positive reports on code coverage. But for now we don't have it. We cannot say that this is missing code coverage, but we accept this. For now, there is no way to do it, so we have to live with what we have. So, it's busted.
I hope everybody convinced.
And there are a few things that we want you to take away from the presentation today. First of all, code coverage is a developer metric. Don't show it to managers. Don't try to assess the quality of your project by code coverage, but but just use it for your development purposes. Then tools are not ideal, as we learned that both JaCoCo, JetBrains coverage engine, and Sonar, and even mutation testing, they're not ideal. They cannot, tell you with 100% guarantee that your tests are of a good quality and that your software is of a good quality. But they're still helpful. You can still use them. And you could see that even while investigating the false positives or some problems with code coverage, we refactored our code, we made it better. But please, never try to please your tools. Never try to write stupid tests of not possible situations. Never try to write mock enums just for the sake of 100%. But use them smartly. Thank you. Thank you for coming, and that's it.